that I saw recently when I was doing some debugging a couple days ago for this UART driver that I'm working on. It has nothing to do with UART, that hardware peripheral. There's nothing to do with that. But it has to do with some undefined behavior when it comes to return values. So look at this function here. It's called UART flush. I have a ring buffer using the non-standard ring span light class library that you can find online. I check to see if it's not empty because, before you want to flush anything, you want to make sure that the thing's not empty. And then after this, we just push back. We basically just remove all the elements one by one until empty comes out to be true. That's fine. Nothing too crazy there. So here I'm actually in the assembly, or like debugging on actual hardware right now. And, we're at the start of the function. I put a little breakpoint here. And, I'd expect in this situation, like if I actually print out mReceive buffer, you'll see that there's this thing called msize that's equal to 0. If I look at the code for empty, it just checks to see if msize is equal to 0. In this case, it is. So the natural thing should just be, just return, or like return early. Check this thing and return early. No, actually it doesn't do that. It pops back. And I'm like, what? How did that happen? msize, like if I print it again, like maybe it wasn't initialized properly, maybe something was weird. No, msize is still 0. If I actually pull out that value, msize is equal to 0, it says true. And if I did the inverse of that, it would have been false, because we're doing not empty, and then that should have been false, and that should have, what happened here. If I actually look at the disassembly here, we see something a little interesting. I wish I could, I don't have all the codes here, but if you notice here, the beginning of the function, we normally push our variables, save some of the variables we're going to be using in this particular function. We immediately branch down to 42.8 to this location here. We run this add function here. We have a load, and then we have a comparison. But this particular set of code here, basically the way that the code gen kind of put this code in here doesn't actually run straight into the pop back issue. And we're going to see this in a more, it's kind of hard to see in this case. So I'm actually going to do is I'm going to show you what I did to try to fix this thing. Oh, maybe I'm going to go real extreme here. I'm going to say, no, we're not doing this. This is too clean. Let's get real dirty. We have some size, volatile, just so we can get all the variables out to force the compiler to do an actual write back to memory. We're going to put in mReceive buffer here. We get the actual size out. We're going to compare some volatile size I with this size here. And we're going to see what happens in this particular case. So I'm going to recompile this. Now load this up. Add my breakpoint. And run. Okay. Here's something interesting. Check this out. So right here, size has not been initialized. Let's initialize it. Now we have size equals 0. Cool. Now we have I is not initialized. Let's initialize it. 0. There's another conditional in here. If I is less than size. And this actually does work for some reason. Skips it. Goes back to here. Now, this should not have even jumped in. The for loops conditional should have immediately have skipped it. But the conditional's been broken in some way. For some reason, the actual code for the conditional just doesn't seem to be there at all. If I go next again, you see that I is equal to 1 and size is equal to 0. That doesn't work. Whoops. And again, and again, and again. And if I just run continue, 5, 4, 3, 2, 1, boom. Look at this number. That's massive. And the conditional's not there. The conditional here is working. You have a conditional here that seems to be doing its thing. And even then, moves R11 load. There's actually no comparison. There's no comparison code in here actually at all. Yeah, the code gen for this thing is all mucked up, completely broken. Not sure what is happening here. It's just looping. Must have figured out that it could. I'm not even too sure what's happening here, honestly. A lot of things are messed up. And here's a way that I fixed it. And I just want you to note that I'm using GCC 10 and I am using optimization level G, not anything higher, just optimization level G. So if I actually put a return statement here, check this out. If I put return brackets. Now this type should be somewhat trivial, but it's not trivial. So there's a constructor for this return value for using boost leaf. If I put this return value here and recompile, and keep the old code as it is. Load it. Okay. Now, come on. check it, size, I, jumps right out. The code gen looks just fine. If you look over here, we actually have the comparisons in the right place, compare it to 0. What else is here? Yeah, there's actual proper, like the proper assembly is here. And it realized that we didn't need to actually run anything and it just would leave. So yeah, that was something that was interesting to me because I never really realized that return statements had any other effect. When it comes to undefined behavior, I always think of it as scoped. Like for example, if you do mathematical operations, I think that the undefined behavior is scoped to just mathematical operations. If you try to divide by 0, I imagine that, you could either, usage fault the system, like the system say, it can't divide by 0, this is a problem, it's going to, yell at you or, run something that checks for that. Or your end result you have is some garbage value, or even if you get stuck in a loop. Let's say it's the hardware is implemented in some weird way, or some algorithms are implemented in some weird way to loop for that. I understand those all make sense to me. Same thing with the return statements. I thought, okay, well, if anything's going to go wrong, it wouldn't be that the code gen for the particular function is going to go wrong. No, I thought the return value is going to get messed up because that's what I missed. I missed the return value, and that anything on that return side would be garbage. That would make sense to me. But I never expected that not having a return value here could actually dramatically and kind of distort and warp the intentions of the code in this location. Now, this actually does go away with O of 0. So just note that, like, if you do O0, no optimizations whatsoever, this goes away. So the code is not doing anything special. It's not doing any optimizations. But I did find it kind of interesting to know that there's undefined behavior with not having a return value for any arbitrary function such that it can actually eliminate conditionals. And I thought that was just a neat little thing to discover. And just, remember, run with warnings on. I have a unit test that I can use to look at it. I just didn't look at the unit test at this time. I didn't think that I needed to. I didn't imagine that, probably no information I gleaned from look at the unit test to see if there's any warnings that pop up. But in the end, I ran the unit test. It told me there's a warning for all these missing return statements when I had refactored the code. And that's when I realized, that could be the problem. And when I finally fixed it, now you can actually see that this thing works just as intended if I remove back and just give it the appropriate return value. I think this is supposed to be here. Yeah. That's not super important where that location of that tab is. Load. Flush. Run. Is it empty? Sure is. Return back out. And we're done. So I thought that was an interesting little thing to look at. So if you ever see finding some really weird bugs or your code doesn't seem to be doing what it's doing, check for things that would normally create undefined behavior. Make sure your warnings are up. W-all, W-pedantic, W-extra. I usually just do pedantic and all. I'm not sure if I use extra. I might use extra in my test. I have to check again. But yeah, make sure your warnings turned on so that you can see this type of problem so you can fix them before they become annoying bugs you're spending hours trying to figure out. All right, that's it for today. Have a good rest of your day.